Question: for each real number x, let gx be the minimum of the numbers 6x plus 3, 2x plus 7 and minus x plus 15. For example, if x is equal to 2, then the three numbers corresponding to these three expressions are 15, 11 and 13. Therefore, gx, which is g2 in this case, is equal to the minimum of 15, 11 and 13, that is 11. Then the question is, what is the maximum? Answer: the graph of the expression 6x plus 3 is a straight line obtained by giving different values to x as shown here in this graph. Similarly, the graphs of the other two expressions are shown alongside here. The graph for 2x plus 7 is this, and the graph for minus x plus 15 is this. Please do it yourself and see that these are indeed. When we plot all the three graphs together in one frame, we get this graph. Here, notice that we have plotted all the three straight lines. The first straight line is this with equation y is equal to 6x plus 3. The second straight line is this with equation y is equal to 2x plus 7. And the third straight line is this with equation y is equal to minus x plus 15. Now the value of gx for any x is defined as the minimum of the three expressions, that is 6x plus 3, 2x plus 7 and minus x plus 15 for that particular value of x. Therefore, when we change the value of x from 0 to 10, the lowest values of these expressions follow straight line segments from P to A to B and B to Q. Now look at the graph and appreciate the fact that these points are the lowest values of the three expressions for their respective x value. For example, when x is equal to 0, we get this line, and here this line intersects the first graph at this, second graph at this point and third graph at this point. Out of these 3 points, this point is the lowest, which is P. Similarly, for this particular value of x, the lowest point is A and the next point is also here, but that is higher than A. So, for this value of x, gx will be here. Similarly, when x is corresponding to this position, the lowest position amongst the 3 graphs is B, because this is the lowest position for this graph. This is also the lowest position for this graph, but for this graph, the lowest position is somewhere here. So gx for this particular value of x is at point B. Similarly, when x is equal to 10, we get this vertical line. There the lowest position amongst the three expressions is here because other points are occurring far above. So, the path that Gx takes is like this, from here to here, then from here to here, and from here to here. So this is what we should appreciate by looking at this graph. So the graph of Gx is PABQ, where x varies from the coordinates of these points P, A, B and Q can be calculated as follows. Point P is at the intersection of the straight lines x is equal to 0 and y is equal to 6x plus 3. Therefore, P has the coordinates of 0, 3. Point A is at the intersection of the lines y is equal to 6x plus 3 and y is equal to 2x plus 7. By solving these two simultaneous equations, we get x is equal to 1 and y is equal to 9. Hence, the coordinates of A are 1, 9. Similarly, the coordinates of the point B are obtained by solving the simultaneous equations y is equal to 2x plus 7 and y is equal to minus x plus 15. That is, 2x plus 7 is equal to minus x plus 15. Therefore, 3x is equal to 8 or x is equal to 8 by 3. Hence, y is equal to minus x plus 15, and that is minus 8 by 3 plus 15 is equal to 37 by 3. So the coordinates of B are 8 by 3 and 37. The coordinates of point Q are obtained by solving the simultaneous equations x is equal to 10 and y is equal to minus x plus 15. This gives the coordinates of point Q as 10 and 5. Finally, the coordinates of point C can be obtained by solving the simultaneous equations y is equal to 6x plus 3 and y is equal to minus x plus 15. That is, 6x plus 3 is equal to minus x plus 15 or 7x is equal to 12. Therefore, x is equal to 12 by 7. Hence, y is equal to 6x plus 3, that is 72 plus 3, 72 by 7 plus 3, and that is equal to 93 divided by. So the coordinates of point C are 12 by 7 and 93 by 7. It is obvious that this point is not on the locus of Gx because for this value of x, that is for x is equal to 12 by 7, Gx occurs at a lower point R, which is shown in the graph. This is point C. However, the lowest point of the three straight lines is occurring at this point, which is therefore a position for Gx for that particular value of x. Now, this is made clear in the graph where the few vertical lines are shown for different values of x. Finally, with reference to the graph, we note that the shape of Gx is as follows. In this graph, Gx is plotted. You can see point P, which is occurring for x is equal to 0, and with the coordinate of 0 and 3, point A with the coordinate of 1 and 9, point B with the coordinates of 8 by 3 and 37 by 3, and Q with coordinates of 10 and 5. So this is the locus of Gx. From this graph, it is clear that the maximum value of Gx occurs at point B, and since this has a coordinate of 8 by 3 and 37 by 3, the value of Gx therefore is 37 by 3 at point B, and this is the answer. This is the maximum value of Gx.